Hi, this video is about distance time graphs and the next video is about velocity time graphs. First, I'm going to explain what the difference is between speed and velocity. Speed is just how fast you are going and has nothing to do with direction. For example, we could say that I'm travelling at 30 miles an hour or 30 meters per second. It doesn't tell us anything about the direction, it just tells us how fast I'm going. Whereas velocity is the speed of something with respect to a direction. For example, I could be travelling at 40 miles per hour in a northwards direction, so it tells us the speed and the direction. So let's look at what a distance time graph is. A distance time graph plots the distance travelled from a starting point against time. Here we have an example of a distance time graph. Time is plotted along the x-axis and distance travelled is plotted on the y-axis. The first thing to say is that the gradient of the distance timeline is the speed. A steeper line shows that the object is travelling faster, and a flatter or shallower line shows that an object is travelling slower. The speed of the object is worked out by doing distance divided by time, but we're going to look at that in more detail at the end of this video. When the distance timeline is completely flat, the object is stationary. If the distance timeline has a positive gradient, i.e. is sloping upwards, it shows that the object is travelling away from the starting point. If the object has a negative gradient, i.e. the distance timeline is sloping downwards, it shows that the object is travelling back towards the starting point. If the line or the gradient is constant over a period of time, it means that the object is travelling at a constant speed. For example, if our distance timeline was sloping upwards and had a constant gradient, it would mean that the object is travelling at a constant speed away from the starting point. If an object is stationary for a period of time, the gradient for the distance timeline will be the same. It will be 0. Therefore, the object will be travelling at a constant speed. If the line is not straight, it shows that the object is either accelerating or decelerating. If the curve is becoming steeper, the object is accelerating. If the curve is becoming flatter, the object is decelerating. So let's have a look at our distance time graph example in more detail. We can split the graph into different sections, and the first section that I'm going to look at is 0 to 15 seconds. Between 0 and 15 seconds, the gradient of the distance time graph is positive and it's constant. This tells us that the object is travelling away from the starting point because of the positive gradient, and the constant gradient tells us that the object is travelling at the same speed. The next section of the distance time graph is between 15 and 20 seconds. In this time period, the gradient of the distance timeline is becoming flatter. This tells us that our object is decelerating. Decelerating means that the speed of the object is becoming less and less. The next section on our graph is between 20 and 24 seconds. At this point, the gradient is flat, and this tells us that our object is stationary. Between 25 and 28 seconds, our object is accelerating, and we can tell this because the distance timeline is becoming steeper, the gradient increasing. Between 28 and 31 seconds, the object remains at a constant speed. Between 31 seconds and 35 seconds, our object remains at a stationary point. It is at 240 meters away from the starting point. The final part of our distance time graph is between 35 and 60 seconds. In this time period, our distance time graph has a negative gradient and the gradient is constant. The negative gradient tells us that our object is travelling back towards the starting point. The constant gradient tells us that our object is travelling at a constant speed. From a distance time graph, we can work out the speed. This is only required if you are on the higher tier examination. We work out the speed by dividing the distance by time. So we do the vertical change divided by the horizontal change. So let's work out the speed of our object between 0 and 15 seconds. At 0, our object is at the starting point, so it's at a distance of 0. At 15 seconds, our object has travelled 150 meters. To work out the distance travelled, we do the distance it was at the end of the time period, which is 150, minus the distance it was at the start, which is 0. This gives us a value of 150. We then divide this value by the time period, which is between 0 and 15. So this is 15 seconds. This gives us a value of 10 meters per second. So let's have another example. Let's work out the speed between 35 seconds and 60 seconds. If you're feeling confident, pause the video and have a go. First, we need to work out the distance that the object has travelled. The object started at a distance of 240 meters away from the starting point, and it travelled back to the starting point. This is a distance of 240 meters. It did this in a 25-second period. So we do 240 divided by 25, and this gives us a value of 9.6 meters per second. This brings us to the end of this video. For more content, quizzes and past papers, go on to www.elevise.co.uk.